Hi, Assalamualaikum, and to the Dr. Gede. So today we like to presenting our project. So today we are exploring the unbroken thread versus the fractured parts. A visual of the undertone of the continuity limits and the mathematics of sudden change. We often think of math as just a number of pages, but today we are looking forward. Is a study of how variables either flow smooth and or is it fractal under the specific condition. In calculus, our ideal state is the continuous function is which when the model smooth predictable change. Mathematically, this means that the small shift in your path or in your input guarantee a proportional shift in your output. The easy way to understand or visualize this concept is the pen test. When if you can draw the entire path from the started point without lifting your pens, that's we call the function is continuous. So to maintain the continuity at any specific point, a function must through all the three mathematically gates. Number one, we call gate the anchor, which is the function of fc must z. Then the gate number two or the approach is the when the limit as x approach the c must z. And the gate number three is the arrival when the limit must exactly equal the function value. It is failed even one, then the thread is broken. Like I said before, if there have no pass the tree, when the three gates check fail, we see a four distinct structure fractals, which means that remover means that a missing step stone where the limit exists but the point itself is undefined. The number two is jump, where represent an instant teleportation when the left and right of the limitation is do not meet together. Next is infinity, when the unimpenetrable barrier where the function approaches the infinity. And the last one is circulating, when the total losing stability where a rapid fluctuation prevent a steady approach.
Autopsy 1, the removable hole. For the first graph, we can see a removable discontinuity, also known as hole. The function given is fx equal x squared minus 4 per x minus 2. When x equals 2, the denominator becomes 0, so the function is undefined at that point. However, we can simplify the numerator by factorizing x squared minus 4 into x minus 2x plus 2. After cancelling the common factor, the simplified function becomes fx equal x plus 2. This means the graph actually follow a straight line, but there is one missing point at x equal 2. To find the limit, we substitute x equal 2 into the simplified equation. So the limit exists and the answer is 4. Autopsy 2, the unbridgeable jump. For the second graph, we are dealing with a jump discontinuity. This happened because the function used two different equations on different sides of x equals 1. From the left side, the graph follow the equation gx equal x plus 1 and the limit approach 2. From the right side, the graph follow the equation gx equal x squared plus 2 and the limit approach 3. Since the left-hand limit and right-hand limit are not equal, the over limit does not exist. Therefore, this discontinuity is called an unbridgeable jump. Autopsy 3, the infinite barrier. For the third graph, we can see an infinite discontinuity involve the tangent function. The function is hash x equal tan x. At x equal per over 2, the cosine denominator becomes 0, causing the function to grow toward infinity. As x approach over 2 from the left side, the function increase positively toward infinity. Meanwhile, as x approach p over 2 from the right side, the function decreased toward negative infinity. Because the function become unbound, the limit does not exist at x equal p over 2. This type of discontinuity is known as an infinite barrier or vertical asymptote.
Good day everyone. Today I want to explore fascinating concept, the real world shock of discontinuity. In the world of physics, nature generally follow a continuous path, meaning things move and change smoothly. However, human-made system, specifically financial regulation and tax code, operate very differently. They are built on strict discontinuous threshold where the rule change instantly. If you look at the visual comparison here, the left side show a smooth organic flow, but the right we see the reality of a progressive income tax system. In the scenario, the tax rate remains steady for a while, but the moment you cross a specific financial milestone, the underlying mathematics completely rewrite themselves. It's a jump curve. It's a series of jump. Alright, let's look at the technical model of this jump. We represent the marginal tax rate as TX. In this specific model, the tax could abruptly change from a 10% rate to a 20% rate. Once income reaches 40,000 ringgit, this creates a literal financial step rather than a smooth transition. From a mathematically standpoint, this is classic case of discontinuity because the left hand limit and the right hand limit do not agree. First, as we approach 40,000 ringgit from the left, lower income, the limit is 0.10. However, the moment we approach from the right, just over 40,000 ringgit, the limit jumps to 0.20 because these 2 points don't meet the function broken at that exact milestone. For the taxpayer, this means that hitting that 40,000 ringgit mark triggered an immediate and significant change in how their next dollar is treated.
Today, I will explain the concept of the bridge that does not exist based on the intermediate value theorem IVT. The IVT states that if a function is continuous, it must pass through every value between 2 points. This is like a smooth bridge where you can walk from one side to another without skipping any hike. In the top diagram, the bridge is continuous, so every value exists along the path. However, in the bottom diagram, there is a tax cliff where the rate suddenly jumps from 10% to 20% without passing through 15%. This creates a gap, making the graph discontinuous. Because of this discontinuity, the IVT does not apply and some values like 15% do not exist. In conclusion, a continuous graph supports the IVT while a discontinuous graph breaks it, just like a bridge that cannot be crossed smoothly. Now, I will explain the difference between the limit and continuity, also known as the approach versus the arrival. In calculus, limit and continuity are closely related but have different rules. A limit tells us where a function is approaching or trying to go, even if it never actually reached that value. This is shown in the diagram where the line moves towards a point, but the point itself is not filled, meaning the value is not actually there. On the other hand, continuity means the function not only approach a value, but also arrive at the exact point. In the second diagram, the point is filled, showing that the function reached the value smoothly without any gaps. In conclusion, a limit about the approach, while continuity confirms the actual arrival at the point.
Okey, mari kita tengok slide yang terakhir, iaitu calculus is the language of chance. Kat sini kita ada nampak ada 4 lah. So saya akan bentangkan satu persatu. Yang pertama adalah the rational function. Sekilas pandang, graf ini kelihatan seperti garisan lurus yang sempurna. Namun terdapat satu titik lubang pada X sama dengan 1. Mengapa? Kerana dalam matematik, kita tidak boleh membahagi dengan sifar. Ini menunjukkan bahawa walaupun sesuatu proses nampak lancar, mungkin terdapat satu titik kecil di mana sistem itu terhenti atau tidak tertarif. So itu adalah untuk the rational function lah. So kita pergi ke the trigonometry function pula. So korang boleh tengok formula yang di atas tu dalam gambar. Y sama dengan tan dalam kurungan X. So ini adalah contoh asymptot. Berbeza dengan lubang kecil tadilah. Fungsi ini meletup ke infinity apabila menghampiri garisan merah putus-putus tersebut. Ini mewakili ekstrim fizikal dalam alam semula jadi. Titik di mana perubahan berlaku secara mendadak dan melampau sehingga ia tidak lagi boleh disambung. Itu untuk the trigonometry function lah. So kita pergi yang seterusnya adalah the piecewise function. So korang boleh tengok formula yang ada di atas tu. So di sini kita melihat lompatan. Graf ini tidak bersambung kerana peraturan yang mengawalnya berubah secara tiba-tiba pada titik tertentu. Ini menggambarkan bagaimana satu sistem boleh berubah mode operasi secara drastik mengikuti keadaan lah. So korang boleh tengok lah, ini dia punya formula yang korang boleh tengok di slide. So itu untuk the piecewise function. So kita pergi yang terakhir, iaitu the finical text bracket. So akhir sekali, contoh yang paling dekat dengan kehidupan kita, sistem cukai, dunia kewangan dan undang-undang tidak mengikuti aliran alam yang lancar. Ia mengikuti ambang buatan. Seperti yang dilihat dalam graf, pendapatan sehingga 50k dikenalkan cukai 10%. Yang kedua, sejurus selepas melepasi 50k tersebut ataupun 50,000, kadar berubah kepada 20%. So maksudnya dekat sini adalah lompatan mendadak ini adalah ketaklanjuran yang dicipta oleh manusia untuk mengatur struktur masyarakat dan ekonomi. Itu saja daripada kumpulan kami. Sekian, terima kasih.